Hi friends, welcome to my channel Biochemics with Ajay MNR. In the previous videos we have discussed various topics like we have tried to solve numericals from electricity. In this chapter, in this video, we are going to solve a question which is appeared in the board exam 2025. It's a board exam question. Please watch the video till the last, and if you have any doubts, please post a comment in the comment box. See, this is the question which is given last year board exam 2025, February 2025 it is given. See how big question it is, which has different parts over here, different parts in a question one, two, three questions, and each part subparts are given here. So once you look at this question, immediately what kind of impression you get here is, such a big question. How should I solve this one? It takes a lot of time. So better I leave to this one and we'll go for which is the easier one. But my dear friends, don't worry about this one. So reading question and understanding is very, very essential. If you read question a number of times and understand properly, the finding the solution is pretty easy for you. We will finish this question within no time. So don't worry about the size of the question. Just go through each and every part. No need to solve at full question at once, but point wise we will try to solve it out. So don't worry. See this one question. This part A here, which has choice 5 marks question. In that first point, if you see, the power of lens is lens X is minus 2.5. Name the lens. They asked lens here and determine the focal length in centimeter. Now that means we have to find out the name the lens. That is the first one. We have to find out the lens name and we have to determine the focal length from this sphere. And third one, for which eye defect of vision will an optician prescribe this type of lens as a corrective lens. Third one, we have to find out what is the what defect it is recommended. This is the first part of the question. Now second part of the question, if you see, first part it is given power, second point it is given magnification of a lens is given. The magnification of lens is given as minus 2 minus 2 using new Cartesian sign convention, and considering that the object distance is 20 centimeter from the optical center of this lens. Now based on these two, magnification and optical distance, we have to find out first what is the nature of the image we have to find out. Second one, size of the image formed we have to find out. And third one, a position of the image, third one. And the fourth one, sign of the height of the image. So first of all, by using this magnification and this distance, object distance, we have to find out all these four things. Now the third part of the question, if you see, the numerical values of the focal lengths of two lenses A and B are 10 centimeter and 20 centimeter respectively. Which one of the two will show a higher degree of convergence or divergence? Give reason to justify your answer. So in this question, what are given? Two lenses are given, AB, and focal length of A is 10 centimeter, focal length of B is 10 centimeter. And now which one is converge or diverge? Why it is so converge or diverge, that we have to give. So see friends, we have seen full question now. It takes almost 2 minutes of time. This is how we have to segregate question into, we have to understand line by line, and we have to search for what are the key points mentioned in the question. Then we have to find out a particular formula, a suitable formula to solve this one. Right? So it's not a big issue. It's a pretty easy actually, because three different concepts are given here. Three different concepts are given here, and all three together they frame as a question for 5 marks. These kind of questions you will see many in board examination. Don't worry about. Now let us see how to solve all of these one. Right? Let us solve these one part by part. Here we have three parts: part 1, part 2, and part 3. Part wise we will try to solve it out. Okay, right. So my dear friends, let us solve the first part of this question. First, here let us write the given data. What is the data given here? The given data here is focal power of the lens p is given as minus 2.5 d. Now my dear friends, if you see the indication, with the indication, and the lens determine the focal length is given. Focal length is given as determine, we have to find out the focal length for this, and after that we have to find out the for which defect it is prescribed. What is the defect of the eye, that we have to identify, right? This is the thing that we have to find out. Now let's see the relationship between power and focal length is power is equal to inversely proportional to of focal length. We know this one. Power is inversely proportional to focal length. That means if power is more, focal length will be lesser. If power is less, focal length will be more. Now let us see. Let us substitute these values here. Power is equal to 1 by focal length. Then focal length we have to calculate, right? Focal length. First thing is focal length. Name of the lens actual. What is the name of this lens? Based on sign convention, name. If it is negative, it is concave lens. Concave lens. If it is positive, it is convex lens. So the name of the lens based on the sign convention. If it is negative, that is concave lens, and if it is positive, that is convex lens. So here power is given in negative symbol, that's why it is going to be concave lens. It's going to be concave lens. Now second thing is focal length we have to find out. Focal length formula f equal to 1 by p. F is equal to 1 by p. Now let us substitute the value. F equal to 1 by minus 2.5. 1 means 1 meter by 2.5 d. That means if you just multiply this with 10, 1 by minus 2.5. 1 by 2.5 means it's 1/4. 1/4. 1 by 2.5 means it will give you 0.4 0.4 meters. 0.4 meters. 0.4 meters. If you convert this into centimeter, that is equal to minus 40 centimeter. Now we got focal length. Focal length is right. Second thing we have calculated. First thing is we have found based on sign convention, it is identified as concave lens. Second point we calculated focal length is 40 centimeters. Now the third part that we have to do. Third one is for which one that we have to. Now third one, for which eye defect. What is the eye defect? Based on eye defect, which eye defect of vision will an optician prescribe this type of lens as a corrective lens? Now we have two types of eye defects. Eye defects we have two types. One is myopia. Second one is hypermetropia. So myopia is also called short-sightedness. Hypermetropia is called long-sightedness. Here, since we are using concave lens is detected. So we know that to detect myopia, concave lens is used. Here, based on the power, we identified the lens given is concave lens. So, concave lens is used to correct the defect of myopia. So, this concave lens, whose power is whose power is minus 2.5D, is prescribed prescribed by optician to correct myopic defect of the person, right? Here we have find out lens type, we have to find out, and the focal length we found, and moreover the defect of the eye also we found. This is how we can find out the answers for part A. So don't worry about it, it's very quite easy, right? Let's go to part B of this question. Now, my dear friends, let's see the part 2 of this question. What is given here? The value of magnification is given, that is minus 2. And using new Cartesian sign convention and considering that an object placed at a distance of 20 centimeter from the optical center of this lens, state the nature of the image formed, size of the image formed, and size of the image compared to the size of the object, and position of the image, and sign of the height of the image. These four we have to calculate. Now let's first find out what is the let's write the given data. What is the data given here? Given is magnification is given as magnification m is given as minus 2. So remember, my dear friends, magnification has no SI unit at all. Magnification is given as minus 2. Now using new Cartesian convention, considering that of that object distance is given as 20 centimeter. Object distance always minus 20 centimeter. These two are given for us, and from these two values we have to find out the nature of the image, size of the image, and position of the image, sign of the height of the image. If you want to find out these four things, you need to find out what is the image distance. Image distance also is required to calculate this one. To calculate image distance from these two values, how can we do? Now let us write magnification formula. Magnification for a lens whose magnification minus given, no? So what kind of lens you feel here? This lens is concave. This lens is it's a right. Let's find out this one. What kind of lens we'll find out with the answer. M equal to V by U. Magnification for lens formula. Lens for magnification for lens is M equal to V by U. From this formula, we'll find out the magnification formula. Now, from this, V we have to find out. V is equal to M into object distance. V image distance is equal to magnification into object distance. Now let us substitute the values here. V is equal to magnification is given as minus 2 and image distance is given as minus 20. Now here minus and minus gets cancelled. Now 2 20s are 40 centimeter. This is the image distance. This is image distance. Now from this we have object distance, we have image distance. Now let us find out the focal length of this one. With the help of focal length, we can say what kind of lens it is. Now from this data we have object distance, image distance, and we write focal length. Focal length formula, lens formula, 1 by f equal to 1 by v minus 1 by u. This is the formula to find out the focal length of a lens. Now 1 by V we know that is 1 by 40 minus of 1 by minus 20. Now 1 by 40 plus 1 by 20. This is 1 by F. Now from this we'll find out, we'll take LCM. 1 by F is equal to, LCM here is 40. 40 plus 41s are 40, 22s are 40. Now it is 3 by 40. Now we need focal length, reciprocal we need. Focal length equal to 40 by 3, that equal to approximate 13.33 centimeter. 13.33 centimeter. Now focal length is in positive, it's not negative. Focal length is positive. Focal length is positive. Generally, which lens has focal length for positive focal length here? Generally, concave lens whose focal length is negative, but for convex lens whose focal length is positive. With the help of this focal length sign convention, we can say that the lens given here is convex lens. It's a convex lens, okay, type of convex lens. Now from this we can find out what is the nature of the size image, what is the size of the image compared to the size of the object. Now position of the image, sign of the height of the image also we'll find out this one from this one. Now this part I'm going to delete, because we have to draw a ray diagram here. Now let's see, let's draw. We have object distance minus 20 centimeter, we have image distance 40 centimeter, and we have focal length 13.33 centimeter. From this data we'll try to draw a lens diagram. Now what lens we are having here? We have convex lens. Convex lens we know that is converging lens. So let's draw a principal axis through optical center here. This is optical center. This is F1 and this is 2F1, and this side this is F2 and this one is 2F2. This is the ray diagram. Now here focal length we know that one. Here this is the focal length over here, that is 13.33. Focal length from here to here, this is the focal length, that is 13.33. Now but object distance here given it as 20 centimeter. No, the 20 centimeter, if focal length is 13.33, what is the 2F1? It should be 26 point. It should be 26.66. That is the center of the curvature, or 2F1. But object distance is given as 20 centimeter. Object distance is given as 20 centimeter. That means object should be between F1 and 2F1. F1 and 2F1. So we can draw object over here between F1 and 2F1, right? Object is at 20 centimeters distance. Now let us draw a line which is parallel to a principal axis. A line which is parallel to principal axis, that should go through focus. That should go to the focus according to ray diagram rules. Now second one, which is that should go through the optical center that converges or that intersect this another line nearly at this place, that converges now. If you see this one, this line which is intersecting somewhere here, this is the intersection point. This is the place where image is formed. Now from this ray diagram we can see that object is between f1 and 2f1. Image is formed behind behind 2f2 behind 2f2 or behind center of the curvature with respect to mirror behind 2f2. So what type of nature here? It is downward below the principal axis. Below the principal axis, this is real inverted image. A real and inverted image. For this nature of the image, what is that? A real and inverted image. Real and inverted image. I'll write here. Just wait here. I'll write clearly. Right here, one a nature of the image is given real and inverted image. Right? Now the second point here. What is second point here? What is second point given here? Size of the image compared to the size of the object. Size of the image compared to the size of the object. How can we see size of the image? Magnification formula again. Magnification is equal to height of image by height of object. We know magnification here is, it is minus 2. Minus 2 equal to height of image by height of object. Now if you want the height of image, that just cross multiply this one, minus 2 into height of object. That means the height of image is 2 times to the height of the object. That means double the height of the image to the height of the object. That's why if it is called magnified. It is magnified. It's a magnified, or 2 times bigger than the image size is 2 times bigger than the image of the object. This is the second one. Now the third one, position of the image. Let's see the position of the image. Third point, position. Where is this one? The position is here. Image position is behind. Image position is here, behind 2f2. So what we write here? Behind 2f2. Image position is behind 2f2. Now the fourth one here is sine of the height of the image. That means, see, this is inverted image. Inverted, that gives a negative sign convention. So this is, my dear friends, see how simple this solving. As I am explaining more, and it may take some time, but while you write it, it takes less than 2 minutes actually. Less than 2 minutes. This is how we can solve this question also. Now let us go to the third part of the question. Now the third part we will see. Third part of the question we see. The numerical values of the focal lengths of the two lenses A and B are centimeter, 10 centimeter and 20 centimeter respectively. Which one of the two will show a higher degree of convergence or divergence? Give reason to justify your answer for 5 marks. This part is not for 5 marks, friends. All 3 parts together for 5 marks, right? Now let's try to solve it. First, let us write always the given data. What is the given data here? Two lenses are given, A and B. Okay, the focal length of A is equal to 10 centimeter and the focal length of B is equal to 20 centimeter. Which one of these show will be more? Right? Which will be show more? The type of lens should be Right. What type of lens we can say here? See, based on the focal length, sign convention. If the sign convention focal length is given negative, that is always right, concave lens. That is always concave lens. That is diverging lens. Diverging lens. Now, if focal length is given as positive, that is the convex lens. Convex lens, that is also called converging lens. So, what they asked here, which one of the two will show higher degree? So, first we could understand from this sign convention, it is going to be convex lens. Both the lenses are convex lens. Both focal lengths are given in a positive, so convex lens. But which shows higher convergence? So convex lens is converging lens. It converges refracted rays, right? So, but how much is difference between these two in terms of convergence? Now let's find out this one. To find out this one, we need to find out the power of the lens here. Power, we know power equal to 1 by focal length. So that is 1 by, for lens A, power is 1 by 10. That gives you 0.1 diopters. 0.1 diopters. Now for B, it is going to be like this. Power equal to 1 by F. Then 1 by 20. It gives you 0.2 diopters of power. 0.2 diopters of power. Now, higher degree of convergence means converge. Here, power convergence means it's a power. It's power. It's power. Whose power is more? And whose power is more? Whose focal length will be less? The power is inversely proportional to focal length. The power is inversely proportional to focal length. Focal length is very less here. Focal length is less than 0.1 D here. A focal length for second thing is focal length 20, 0.2 here. So the power whose focal length is less, will be more convergent. Will be more convergent. Power less here. Power is less when comparatively. Whose power is less, that will converge more. So here power of the lens A is lesser than power of the B. Power of the B. So A is higher convergence. A is higher convergent here. This is how we can say which lens is more convergent, whose focal length is less. Lens A focal length is 10 centimeter, lens B focal length is 20 centimeter. Here lens A, it converges at less focal length, lens B converges at a more focal length. That's why the one which converges at a less focal length will be more convergent. Degree of convergent will be more. So here the correct answer for here lens A has higher degree of convergence. So friends, we can solve this problem. To solve this problem, almost we have taken more than 20 minutes. As I am explaining this one, it takes a lot of time. But while if you practice and go to the exam, it will take not more than 5 to 6 minutes. Okay, this is how in next class also I will come with another board model question physics, and this is how I am going to upload you videos continuously based on board questions, physics, chemistry and biology. So thank you for watching. Have a nice day. Please like my video, share it and subscribe it. Thank you.